Hi, I'm Kim.
And I'm Brian.
And this is our game Logical Land. In our game, we chose to represent the mathematical model of a multiplexer. A multiplexer, also known as a mux, is used in circuits. Its main goal is to choose which input becomes the output. In order to express the equation y equals a times s plus b times not s, there needs to be an explanation for and, or, and not gates. The user will go through a tutorial of these gates before being able to go to the multiplexer. The first gate we will look at is the OR gate. We shaped all of the gates to be representations of the symbols. So initially, the user will be given instructions. They will take either a glowing orb, which represents true, or a rock, which represents false, and place it on the hot air balloon. These two hot air balloons represent the inputs for the gate. When both inputs are filled, the user will jump onto the cloud to start the animation. The hot air balloon inputs will move around the OR gate and reach the cannon, which will determine the output. In an OR gate, if one of the inputs are true, the output will always be true. Users have the opportunity to try all possible inputs: true, 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 false, and false, false. For demonstrative purposes, we will move on to the AND gate next. Next is the AND gate. The AND gate is similar to an OR gate because there are two inputs, and each input needs either a true or a false. The user interacts with the AND gate the same as an OR gate. So after the two inputs are filled, they will hop on the cloud to see the animation. An AND gate, however, works differently than an OR gate. For an output to be true, both A and B inputs have to be true. In an OR gate, it was just one or the other. The next and last gate we're going to look at is the NOT gate. The NOT gate is a little different because it only takes one input. The NOT gate is basically just an inverter so that the output will display the opposite of the input. For example, because a false is placed there, when the user hops on the cloud, the input should be a true because it's the opposite.
Now that you've learned about the three main gates in digital logic, you can have the opportunity of pressing X to reset the game or to try different inputs. After the user is familiar with how the AND, OR, and NOT gates work, it is time to move on to the multiplexer. The multiplexer is a device in logic design that is used to select inputs and designate them to outputs. The equation of a multiplexer is y equals as plus bs naught. Y is the output while a and b are the inputs. S is a select line that determines which input moves to the output. The multiplication in the equation is signified by AND gates, while the addition is signified through OR gates. As you can see, you can select which input data to put into the A, B, and S lines by grabbing a glowing orb or rock and holding X near each balloon. After you've given each one, you can press Y to see what happens inside of a multiplexer. As you can see, there are two AND gates and one OR gate, which determines the output. The output is determined based on the select line. If S is true, then Y equals A. If S is false, then Y equals B. So this is our game for learning about multiplexers as well as AND, OR, and NOT gates. We hope you've learned something and hope you enjoy our game. Thank you and have a nice day.